Hi, thanks for joining us. My name is Jason with LA Networks / Net.Academy. This is going to be our kickoff today in AWS for gateway objects. And we're going to start with the Internet Gateway, probably the most common of the gateway objects, if I'm being honest. It's up there with the customer gateway at least, right? So we've got a lot of things. This entails talking about subnets, VPCs, NATing, routing, all of those concepts that we've covered before are going to be covered here, just specific to the Internet Gateway. You're going to see a common theme starting to emerge where we take those fundamental concepts and now we start to build out more and more complexity. So if you need to, feel free to go back and check out those earlier videos. If you're set, no worries, we'll dive right in. As always, if you're enjoying our content, please consider giving us a like and a subscribe. If you'd like to be notified when we update videos, please go ahead and click the bell icon in the channel. Thanks so much, and let's dive right in. We're going to have a quick overview on what gateways are in general in AWS. Anytime you hear the term gateway, and there's a lot of products that have that term, we won't cover all of them, but we'll cover several of them. I want you to think of a routing solution. AWS refers to routing solutions with gateway in the title somewhere. What are some of the more prominent ones? There is the Internet Gateway, which is used to route to and from the internet. The Virtual Private Gateway, which does dynamic routing via BGP across IPsec tunnels. Customer Gateway, this is anything that routes to and from an AWS controlled resource, and they don't control the other end. So if you have SD-WAN or those BGP via VPNs, your side of that is the Customer Gateway. Transit Gateway, which is a region-wide construct that AWS uses to route between VPCs within a region or even route between VPCs in other regions by doing TGW peering. And last but not least, we have the Direct Connect Gateway. This is if you're going to have Direct Connect circuits, which are basically private fiber-based circuits between yourself, your on-prem, and AWS, you can use a Direct Connect gateway to peer it directly to, for example, your TGW. There's other uses for the Direct Connect gateway. The real takeaway here is when you hear gateway, I want you to think routing solution. So the first gateway we're covering is the Internet Gateway, right? This is a VPC level construct. This means it automatically spans all availability zones that the VPC participates in, right? They're really simple to create. You just need the VPC name, because after you create the IGW, you need to attach it to one of the VPCs you have. It's effectively a gateway to the internet and a NAT device all rolled into one. We're going to talk a lot about NAT in this session because NATs are very important to IGWs. The IGW is automatically redundant across all AZs in the region that the VPC participates in. Also, the IGW is always auto-scaling in bandwidth. Now, be aware that doesn't mean that when you spin up an instance in your VPC and you have an IGW in there, that instance has infinite bandwidth to the internet. It does not. You could still be constrained down at the EC2 level or at the ENI level, right? Different instances will perform very differently. So be aware of that. Real quick, let's talk about some nomenclature which comes around a lot with internet gateways, and that's the concept of public and private subnets. We'll define private subnets in the next slide. The public subnets are where all your servers and services are going to go if the internet is allowed to initiate connections into those servers or services, right? So the only thing that should ever go into a public subnet is something that you're expecting to host a public service that needs to be reached, i.e. initiated a connection with from the internet, right? If it doesn't have that requirement, it does not go in a public subnet. So everything in a public subnet typically has a NAT. And again, we're going to talk a lot about NATs. This gets to my recommendation when it comes to IGWs and public subnets in particular. I want you to very strictly control what is allowed in and out of public-facing subnets. You're going to do this typically through security groups. Every EC2 or every instance that goes into a public subnet is going to have a very strict security group attached to it that only allows in the ports which that server is meant to listen to. You do not want to be in a situation where you're troubleshooting and you just open up an IP any to your server. I see it way too often, and it shouldn't really happen, not in a public subnet. Might be a little different in a private subnet. Your mileage could vary there. But when it comes to those public subnets, I want you locking them down. Hopefully that makes sense. It's just so critical. That's why I'm harping on about it. The next two slides are going to deal with NATs. We're going to deal with NAT in two different ways. The first is, how am I going to do NATs for that public subnet, right? So we just defined what the public subnet is. Obviously, I said everything in the public subnet has a public IP address. You can do this in one of two ways. You can either use an elastic IP, which I prefer, and I'll describe why, or you can do something called auto-assign public IP. So both will appear on the host itself, meaning if you go into the instance and you go to the networking tab and you look at their NICs, you'll see some of the NICs have a public and a private IP address. It's a little bit disingenuous. That's probably the wrong term, but it's not the real state of things, because really that public IP is not on the server at all. It's actually off server on a black box kind of sitting in front of that internet gateway, which is doing NATs for you, right? The important part is to know that you do have a NAT on those different things. The reason I don't care much for auto-assign is they can only be configured or enabled at instantiation and then never again. So it's a one-time process, right? Also, the IP can change every single time that the server restarts. Again, I don't like that. That just seems to be a security nightmare to me and an operational nightmare as well. I like elastic IPs because they're more permanent in nature, right? So again, my recommendation, I would use elastic IPs over the auto-assigned since they don't change. And in general, they tend to be more flexible. If you want to change them out, you can. Remember, those auto-assign, it's only instance instantiation. So just be aware of that. What about for devices that don't go in the public subnet? Well, Amazon has this concept of a private subnet. This means devices that can go out to the internet, but the internet is not allowed to initiate connections into the private subnet, right? For those types of devices, we still need a NAT, and that NAT is accomplished on something typically called a NAT gateway. You have other options. You don't have to use a NAT gateway. You could use a network appliance like a firewall or something like that, but we're going to keep it simple and say you're going to use a NAT gateway. NAT gateways are availability zone level constructs, right? So they can only be in a single AZ. Be aware of that, because if you have a resiliency requirement, you may need more than one NAT gateway, right? If you're in two AZs, AZ1 and AZ2, and resiliency is critical, you have an app that requires it, for example, then you may need a gateway, a NAT gateway object in both of those availability zones. The NAT gateway always goes in the public subnet. Why? Because the NAT gateway gets an elastic IP, right? Everything in the public subnet gets a public IP. NAT gateway gets a public IP via an elastic, so it goes in the public subnet. The NAT gateway, though, is definitely a security device because it only allows traffic out. It does not allow traffic initiated in. It is stateful. So if I have a server in a private subnet that goes out through the NAT gateway, the return traffic is allowed in, but the internet at large cannot initiate traffic in through a NAT gateway. It will drop, right? So I want to talk real quickly about public and private subnets, right? Again, it's just really important you remember a public subnet by AWS's definition is a subnet where everything in it has a public IP address. You should not have a lot of stuff going into public subnets, right? Private subnets are basically where we have all private IPs, and instead we go through a NAT gateway. By the way, how do we go through the NAT gateway? We go through the NAT gateway by putting a separate routing table in our private subnet tier, and we point the default route to the NAT gateway object. It's also important here to note that if you're going to have multiple NAT gateways, then you're probably going to need to have multiple private routing tables, one per subnet or per availability zone, really, right? So if I have, exactly as I've drawn it out here, I have two NAT gateways, one in AZ1, one in AZ2, I would need to double my private routing tables and break one out and associate it explicitly with private subnet 1 and a second routing table and associate it with private subnet 2. And then I would have to do something like set up a default route on the first one that goes out the same AZ-based NAT gateway and set up a route on the second one that goes out through the second NAT gateway. Your other option is you could, if resiliency is desired, but it's not critical for your app, you're okay to take an outage or something. You might be able to do something like create a new NAT gateway on the fly and reprogram the routing table. Definitely beyond the scope of what we're going to cover today, but you could probably do something along those lines with something like a Lambda or Terraform or some other solution, right? So that's another option. Again, kind of out of scope from what we're covering. So just be aware that if you have a resiliency as a requirement, you may end up having to create more NAT gateways than you originally intended to. Hopefully all of that made sense today. I want to thank you, as always, for taking your time, and we'll catch you on the next session. Okay, that was a lot. Thanks for joining us today on this. Let's just talk about some final thoughts here, right? We talked a lot about internet gateways. Anytime you're connecting to the internet, whether it's on-prem or in the cloud, security should be job one, right? That's the first thing we're going to deal with. And so I want you to be very cognizant of that public-private boundary and thinking about what it means to be a public server, right? We don't want to put services in our public subnets that don't require internet connections initiated from the internet into the subnet. If they're going out, they don't need to be in the public subnet. They can go in the private subnet. Also, I want you to remember, you're going to see this concept of public-private subnets all the time in AWS documentation. You don't have to do them. You don't have to have them. I have plenty of customers who prefer to bring their internet maybe on-prem, or perhaps they prefer to do a single centralized VPC for private and public access, or for public access, really. So your mileage could really vary there, right? It depends on your needs in your company and what your policies are, not what AWS tells you, right? I want you to think about what's important to your company. Every device that goes into that public subnet, though, it needs to have a lockdown, firm security group at a minimum, right? Hopefully that makes sense. Anyway, I want to